Welcome to Octosci Academy. Today's class is the continuation of the gas law. Today we will be looking at Dalton's law of partial pressure. By the end of this video, you will be able to understand what it means and do simple calculations on Dalton's law of partial pressure. So the law states that the total pressure exacted by a mixture of gases is equal to the sum of their partial pressure exacted by each individual gas in the mixture. The partial pressure is the pressure that each gas will occupy when on its own in the mixture at the same temperature and pressure. So for example, the total pressure exerted by a mixture of two gases A and B is equal to the sum of the individual pressure. This can be illustrated as seen in the next slide. So we have gas A plus gas B. We have a mixture of gas A and gas B together. That is what Mr. Dalton is trying to say, that the summation of the partial pressure of A and B gives the two together. So mathematically, the P total for several gases is equal to P1 plus P2 plus P3 and so on and so forth. I mean, it continues as long as you have more than one or two gases in the mixture. So the summation of the gases makes up the total pressure that is exacted. That is what that law means. Also, partial pressure can also be expressed by this. That is PA given as partial pressure of the pressure of A into XA times PT. XA is equal to NA over NT. So what does PA mean? PT here means total pressure of gases. The XA is mole ratio of the gas A. NA, number of molecules of gas A. NT is the total number of molecules of gases in the mixture, while PA, which is the partial pressure. So we can also find partial pressure of gases using that second formula. So we are going to use that in this exercise. In a closed vessel, the following gases are kept in the vessel: 0.25 mole of carbon dioxide, 0.15 mole of oxygen, 0.10 mole of nitrogen. So we are asked to find the partial pressure of each gases. We have been given their total pressure to be 135 Newton per meter square. So we are going to solve each gases differently according to this law. So the first gas using PA equals XA times PT. So our Na, remember the first gas is carbon dioxide, which is the number of moles of that. It gives 0.25. So we would divide it by the total moles of the three gases. It gives us 0.5. Then multiply by 135. And at the end of the day, we have 67.5 millimeter mercury. Now for the second gas, which is oxygen, the number of moles is 0.15 with the total number of the moles, and then PT, which is given as 135. So we substitute 0.15, put in the values, divided by 0.50, the total moles, times 135, the total pressure that is given. We have 40.5 millimeter mercury for the second gas B. For the last gas C, we use the same formula. The moles is 0.10 divided by the what? The total moles. Then we get multiplied by what? By the PT total. So that is 0.10 divided by 0.50 times 135. Our final answer for the last gas is 27 millimeter mercury. So at this junction, we have been able to find the partial pressure for each gases. So next is a personal test you can try your hand on. You have to find the partial pressure of these gases. So remember, the more you solve, the more you get it easier. Thank you for watching and see you in the next video. Don't forget to follow us on Facebook, Instagram, and TikTok, and especially on YouTube at Octosci Academy. Please share. Bye for now.